Question 1. Ethanol is oxidized to ethanoic acid using acidified potassium dichromate solution. The reaction is heated under reflux using the equipment shown in the diagram below. So you can see we have a round bottom flask here, we have our condenser sitting on the top, so a setup for reflux. What is the reason for heating under reflux? This is a process you will have carried out in your practical work, and it has been mentioned to you on a few occasions what the point of refluxing is. It's fairly obvious, to be honest. Quite a lot of your organic practicals, your organic reactions, take some time for them to happen. So you need to constantly heat this substance up. And if you don't reflux it, when you're heating it, it's going to all boil and evaporate away, and you're going to lose everything. So if you look at your options, is it to ensure even heating? Is it to prevent any substance escaping? To boil the mixture at a higher temperature? To allow efficient mixing? It simply is to prevent anything escaping. So as these chemicals boil, the vapours will travel up into the condenser, into the Liebig condenser, will condense back down and fall back into the flask. So refluxing is to ensure that you don't lose anything. So the answer to that is B. Butanol is reacted with acidified potassium dichromate using the apparatus shown below. So you can see here this is different to the first question. We've got the condenser now sat on the side. We have a side arm connector and a pear-shaped flask, and we're catching the product as it falls out of the condenser. What is the organic product? Okay, so the question is asking about butanol. You can see here we are going to be heating it and oxidizing it with acidified potassium dichromate. So an alcohol can oxidize into an aldehyde and a carboxylic acid, or a ketone, depending on what type of alcohol you've got. Butanol, you think about the structure, would look like that. Our OH group, our hydroxyl group, is attached to a carbon bonded to one alkyl group. It's therefore a primary alcohol, and primary alcohols can oxidize into an aldehyde partially and then completely into a carboxylic acid. Because we are distilling and catching the product here, we're preventing complete oxidation. So butanol will oxidize under these conditions to butanal. So if you go down to our options here, our options for this question are butanone, butanone, butanal, and butanoic acid. So the answer is C. The skeletal formula of an organic molecule is shown below. Which of the following statements is or are correct? Okay, look at the molecule. It's not asking you to do anything other than identify the functional groups. So what have we got here? Well, I can see an OH group on the end of the chain, so there's a primary alcohol here. I've got a double bond O and I've got an NH. Now you could be fooled into believing this is an amide. It is not an amide because the carbon double bond O is not directly next to the NH. So for this to be an amide, this would have to be there, or this would have to be there. You need the NH and CO on adjacent carbons. So this is a ketone and this is an amine. Okay. Normally, when we've looked at this so far, we've looked at amines in terms of NH2. That's a primary amine. If you carry on removing hydrogens, you take your primary amine and turn it into a secondary amine. If you take this one away and replace it with another carbon chain, it becomes secondary amine. You take this hydrogen away and replace it with another carbon chain, it becomes tertiary amine. So this is a secondary amine. So our options: the molecule contains an amine group. Well, it does. It's there. The molecule contains a carboxylic acid group. No, it doesn't. Again, you could be fooled here into believing that's a carboxylic acid, but the double bond O would need to be on the same carbon as the OH. It's not. Okay, it's just not a carboxylic acid. And the amide group, again, that's not correct. They're not next to each other. So the only true statement is this one, statement 1. So the answer is D.